Okay, there's going to be some products here that are special products, like we're going to notice something about them. So when we multiply two things together, if we notice that they're basically the same, this binomial is the same as that binomial, except the only difference is the sign in between them. One of them is positive and one of them is negative. Okay, those are called conjugate pairs. So we're going to look at how we multiply conjugate pairs. And what you do is, when I multiply this out, let's take a look. A is just some number. It could be a 2 or a 5. So, but let's look. We go, the first thing when we distribute the x. So x times x gives me x squared. So I'm going to multiply the x times the x to give me the x squared. Then what's going to happen next is I'm going to distribute the x times the negative a, and it's going to give me negative ax. I'm not going to highlight that part because you're going to see what happens. So now I'm done distributing the x here in the first factor. Now I'm going to move over to the a. If I distribute the a, I do a times x. That's going to give me a positive ax right here. And then when I distribute the a to the a, I get a positive times a negative. I'm going to get a negative, and then a times a is a squared. So a times negative a will give me a negative a squared. And that part is right here. If I go a times negative a, I'll get the negative a squared. Why did I not highlight the middle parts? Because what happens now when I add these together, if I have negative ax's plus positive ax's, these will cancel out. For instance, if it was like negative 2a plus negative 2x plus 2x, they would cancel out. And so I'm just left with my x squared and my minus a squared. So if you notice this situation where these are the same except they only differ by the sign, you don't have to do the whole FOIL thing. You could just go x times x gives you x squared, and then a times negative a gives you minus a squared. And I will point out that this right here is called a difference. Why is it called a difference? Because it's subtraction. Subtraction. It's always going to be subtraction when you multiply these special situations out. Difference of two perfect squares. Okay, perfect squares are numbers that can be square rooted. So x squared can be square rooted and a squared can be square rooted. I should say can be square rooted for an integer value. So a perfect square is something times itself, an integer value times itself, or a variable times itself. So a squared and x squared. So let's look. It'll make a little more sense if we do some examples here. So I notice that when I'm multiplying these out, that these are pretty much exactly the same except one's positive and one's negative. So I don't need to do the whole FOIL thing we were doing in class, or if we did the box method, right? I don't need to do all of this. Right? I don't need to do all the steps of that. I just need to do the first times the first and the last times the last. And you might not need the box for that then. So I would just do the first times the first and the last times the last, because the middle parts in the box, like this part that I would have gotten here and this part I would have gotten here, cancel out. Watch. If I do the box method, x times x is x squared, and then this would be a positive 2x, and this would be a negative 2x, and then this would be a minus 4. Then we're supposed to add these together if they're the same. Well, these are always going to be exactly opposite when you have this situation with the plus and the minus and everything else is the same. These will always be opposite, therefore they will always equal 0 when I add them together, and I will always end up with just this part and this part. So I don't really need to do the whole box thing. If you notice the situation, just do the first times the first. X times x is x squared. The last times the last. Negative 2 times positive 2 is negative 4. And that's your answer. All right, let's try it again. So I notice here that these are pretty much the same binomial, except this is a minus sign and that's a plus sign. So these are called conjugate pairs. When you multiply conjugate pairs, the middle parts cancel out. So I just need to do the first times the first, which gives me x squared. I'll highlight it. That's where I got that from. And then we do the last part times the last part, which will give me negative 5 times positive 5 is negative 25. And that will give me, the last part. All right, so without all the highlighting, x squared minus 25 is our answer. All right, let's look at this next one. Again, I notice conjugate pairs. This binomial is exactly the same as this, except the sign in the middle is different. So I'm going to just do the first times the first, so 2x times 2x. And then the last times the last, negative 11 times positive 11 is negative 121. A positive times a negative is a negative. Please note that whenever you do this, it's always going to be minus, 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 right? Let's look at the last one. So I notice that these are conjugate pairs because they're exactly the same, except the sign in the middle is different. So 6x times 6x is 36x squared. And then negative 14 times positive 14, a negative times a positive is a negative. I don't know what 14 times 14 is. Let's see, 14 times 14. I go 16, 56, 0, 4, 1, 196. All right, so that's how you multiply those guys out. Whenever you have conjugate pairs, you multiply them, the middle terms cancel out, and you always get a difference, a minus sign of two perfect squares.